Hello, friends. Welcome back to General Science. This will be our last episode, and we're going to be learning about climate change today. And that'll be probably the best way to end our series because, of course, climate change is the biggest, kind of most looming threat scientists face today, maybe other than censorship, but that's not something we can talk about here. We're talking about this right now. So let's start. Let's talk about climate change. Here's kind of an overview of what we're going to talk. What is climate change? The data that supports it, and then some conclusions and projections that we have. So vocabulary, what is climate change? Well, first of all, we got to talk about climate. Climate is the overall pattern of weather in an area. For example, the Amazon has a tropical climate, right? It is warm and wet, and that's just the general trend of the weather there. This is different than weather. Weather is the day-to-day kind of weather, like the day-to-day kind of thing. Yesterday was cold and windy. Today it's warm. That's weather. Climate is the overall trend, right? You can think of it as weather being a data point, whereas the trend might be up, right? That is what climate is, a trend. Now, what is an extreme event? We're going to be talking about these a little bit. And an extreme weather event is just weather that strays far from the norm, right? It being super hot in Alaska, there being hurricanes, right? And having powerful tropical storms in non-tropical areas. That's an extreme event. It's outside the norm that we're accustomed to. So now that we know those two pieces of vocabulary, we can really start to understand what climate change is, global climate change. So let's take a look at some data. Now, on this graph, we have global temperature that we've been recording since the 1880s. Each dot is the average for that year, and then the red line is the 5-year average. So as you can see, in this time period when the Industrial Revolution was just starting, it stayed around here. But then when we hit the 1900s, this is when we started using fossil fuels at a higher rate. This is when we started using cars. This is when we started using airplanes. This is when we started going to these big wars where we were using all these resources. And as you can see, right, the global temperature was rising. And then right after World War II, it dipped a little bit, right? We weren't using it as much. We weren't at war. We weren't using this petroleum as much as we were. And then as you can see, right, starting in the 80s, it started to increase and increase and increase and increase and increase. And our temperature has been going up ever since. This graph isn't as up to date as it is now, but it has continued to increase. Each year for the last 5 years has been the hottest year on record overall on average. So, right, global temperatures are rising. There's data to support this that we have measured. It is there. We can also take surface temperature maps, right? Here we have the warmest and the 9th warmest surface temperature maps, and that's for 2007, right? So the warmest land temperature at the time was the warmest. As you can see, it's very red, high being good, like really high. And then even the water, right, the surface temperature of the ocean was the 9th warmest in 2007. It has since gotten warmer. So this is old data. This is no longer the warmest because it's been passed up many times since then. In the 15 years since, right, it has continued to increase. We also have the frequency of heavy precipitation events, right? And it's increased over land areas. And that's consistent with warming and increases of atmospheric water vapor. And so more intense and longer droughts have been observed since the 70s, and those have been particularly in the tropics. So as you can see, right, we are getting more rain, more precipitation in areas that didn't usually get it, and we're getting less and less in areas that normally would be getting it. So the overall climate in this area has been changing, and we've tied that to temperature increases. And then, of course, the big smoking gun is the greenhouse gas concentrations in the Earth. And we have data that goes much further back because we can measure carbon dioxide concentrations from ice cores. So as you can see, right, the amount of carbon dioxide in the atmosphere has increased exponentially in the last basically century, right? To a point that has never been seen before in human history. And the same can be going for methane concentrations. So these two gases are greenhouse gases, and they are responsible for trapping heat on the planet. That's why our planet is warm. That's why our planet is habitable, because we have an atmosphere that traps heat on the planet. Otherwise, we'd be too cold. We wouldn't be able to exist. Now, this spike is keeping too much heat on the planet. It's becoming too hot because we're trapping too much heat. And all of this is coming in the last 250 years, which is when we were starting to burn carbon at an increasingly high rate. So carbon dioxide and methane, right? Carbon. And therefore, we haven't been able to, we can see that those things are coming up, and we can tie it to an actual event that we know, right? The burning of more carbon in our atmosphere. So what are some conclusions and projections based on that data that we just looked at? Okay, first of all, the projected surface temperature of the Earth is going to continue to increase, and it could increase by a lot. As you can see, there's a possibility that by the end of this century, the Earth might be over 8 degrees warmer than on average than it was right now where we are. That's not good, right? Global temperature increases, right, we've shown have consequences that are pretty dire for us. Okay, our CO2 concentrations could also continue to go up. These are all sorts of different projections of where it could go, right? And it's potentially going to go even higher if we can't stop the burning of fossil fuels. So we do have the issue there of CO2 concentrations continuing to climb at such a high rate, which would make the Earth even warmer. And that would, of course, right, see that the global temperature would then get even hotter. So this is days in a year where the average temperature is over when the daily low temperature is in the top 10% of the warm nights. As you can see, right, didn't happen very much until about 2000, and now it's happening all the time. So not great, right? More evidence that temperature is increasing. We're also going to see ocean level rise. Here is the southern United States, and you can see all of the light blue areas are areas that will no longer be land anymore because it'll be covered in water. This here is Florida. Only a small section of it will still be above the water level. This is the entire east coast of the United States, including New York and Boston and a bunch of these other big city centers. And this is the Mississippi River, which will start flooding. So the southern United States will be covered in water. Over here is the England, which has lots of tributaries of little rivers that flow out. And so the English Channel will swell. This is London. This is most of eastern England. And then this is northern France and the Netherlands. The Netherlands will be gone. And this is all potentially in the next 50 to 60 years if we continue doing what we're doing. So what are the impacts of climate change? Well, as climate change changes, right, humans are going to find it more and more difficult to survive. We're not meant to change that rapidly. And so our species is meant to survive gradual changes over several generations and not these rapid changes over the course of one lifetime. So as it continues to change faster and faster, we're going to find it harder and harder to keep up. It's also going to decrease the biodiversity of our planet. Other living species, not just us, are not going to be able to adjust like maybe potentially we will be able to. And species loss is going to decrease our planet's biodiversity, and that's going to accelerate extinction across the planet. So we're going to be losing more and more ways of life. It's also going to damage our food supplies. Changes in climate is going to affect the ability for us to grow food and for us to raise the animals we eat. Right? Those animals won't be able to survive as easily. The plants we eat are going to struggle in these soaring temperatures, and overall, our ability to feed ourselves is going to diminish. Not only that, the amount of drinkable water is going to decrease because that salt water will eventually contaminate our freshwater reserves, which makes the little drinking water we do have an even scarcer commodity. Lack of drinking water oftentimes lead to violence and war. Okay, which already is happening in countries like or in continents like Africa and Asia, where people fight over water rights. Now, some animals are going to be able to thrive in these new environments, and those animals that are able to adapt are going to rapidly change, and they're going to be able to leave their usual habitats and branch out. And these species will be able to take over areas they move into due to lack of predators that are capable of fighting these new animals. Think about the things that live in really warm temperatures. They're going to be able to move into areas they're not normally are. We're talking about like snakes and spiders and scorpions and stuff like that. They are going to be able to thrive in these warmer temperatures, and they're going to be able to move further and further north. Not only that, right, we're going to have higher ocean levels, which is going to decrease the amount of available land we have for us to stay safe. Areas of the world that are already crowded become even worse with influxes of environmental refugees, and these high concentrations of people will lead to disease and famine and speed up the cycle of death brought on by this changing climate. So areas like the United States, where we have more open land, where we can take these people that are going to be displaced by all this environmental damage, are going to be okay, but countries like India and China, who have so many people and not as much resources, aren't going to be able to do this. And it'll speed up this kind of spiral of death due to climate change. So what are some solutions we can use to combat this issue? First of all, we need to drastically decrease the amount of CO2 that we're putting into the atmosphere. Corporations are the largest contributors of carbon dioxide emissions, and that's not necessarily a country. These are the corporations that are living in the countries, right? Corporations need to drastically cut back their emissions if we still want to save this planet, and that means we have to be smarter and more efficient, and we need to invest in cleaner processes for doing what we need to do. We also need to increase our ability to capture carbon dioxide from the atmosphere. We are working on new technology that will allow us to capture carbon dioxide and take it out of harm's way. And this technology would allow us to capture and store CO2 so it won't be in the atmosphere. Basically, we would be capturing the gas in our atmosphere and we would turn it into solid bricks and then bury it. So we'd have carbon dioxide stored back under the crust of the earth again. We also need to increase our reliance on alternative fuel sources. That means solar energy, fusion cells, which we're getting closer and closer into making efficient, geothermal energy wherever we can use it, wind energy, hydro energy, and when it's safe, nuclear energy. So there's lots of different ways that we could potentially, change how we fuel our society. And some places have embraced that kind of thing, while others haven't. So we need to convince the places that haven't that this is something that is capable of fueling their societies. We also need to make a big effort into regrowing the jungles and forests that we have destroyed over the last 100 years. The jungles and forests across the planet are being cut down by the logging industry, and these areas are responsible for capturing carbon dioxide naturally. The Amazon is shrinking, other rainforests are getting smaller, and without these areas capturing CO2, the amount in the atmosphere has been able to rise because we can't absorb as much as naturally we would have been able to otherwise. So by restoring these areas and making them once again luscious and green, we can begin pulling more of the CO2 out of the atmosphere. Thank you so much for watching our final episode of General Science and for watching the series in general. It's been a lot of fun teaching you guys about science. And once again, I'd like to point out, if there's anything that we didn't cover in this series that you think you'd like to learn about, go ahead and drop a comment on any of my videos, and I'll see if I can put a special episode together and cover the things you want to learn about. I'm always open to doing more. Thank you again, and we'll see you next time we want to learn. Whee! Peace out. See you later.